everyone, welcome back to my channel EduVibe. Today we're doing another topic of the momentum and impulse, which is the iterations classification in two dimensions. So it's the same topic like copy we do in the one dimension where we deal with the kinetic energy, and if the kinetic energy is equal, so it's the elastic collisions. If it's not equal, so it's inelastic collisions. So same aspect we do on the two dimensions. So as you've seen in the when we're doing the non-right angle iteration, so it's the same question, and now they want us to whether collision is elastic or inelastic. So they're given us a 15 ball velocity, which we find from the iteration when we're doing in the previous lesson. So it's the same question kind where the masses of cue ball we have given, we have a mass of M15 ball, we have a velocity initially for the both, and then we have a final for the both also. So let's find the kinetic energy initially and the final for both. Eki is equal to ek1 plus ek2. For one is initially is there, we have initially for cue ball this one, and but we this is in stationary initially, so it goes to 0. Kinetic energy is 0, so it goes to 0, and we only have Eki is equal to half m1 v1I square. So for this, mass is 0.170 kgs, and we have a velocity of 0.500 meter per second scale. So we get Eki of about 0.02125 joules. For Ekf, so Ek1 plus Ek2, we have a velocity final for both. So we take both as kinetic energy, which is half m1 v1f squared plus half m2 v2 f squared. So this is half 0.175. Final for this is given to us, which is 0.355 squared half m2 is 0.185 kgs, and the final we find 0.176 square. So that Ekf, when we calculate this, we get about 0.01357 joules. So here Eki is not equal to Ekf. So this means this is the inelastic collisions. So this method goes the same as one dimension. Sometimes you get the graphs type of question, like we have to find those through the graph. Sometimes the graph involves in two-dimensional classification. So how this works, so we deal with this now. So we will deal with the diploma example. So this is from the diploma, official diploma exam. So how can we deal with? Let's see. So they mentioned a student performance experiment using the two fictional laboratory carts. A piece of timer tape is attached to cart 1 and feed through a spark timer apparatus. The timer makes a mark on the tape each 0.10 seconds. Cart 1 is pushed toward the cart 2nd, which is initially at rest. The carts collide, the piece of clay is deformed and holds the cart whereas they continue to move. So the mass of cart 1 is given to us, which is 1.54 kgs. And the students repeat the procedure manipulating the initial speed of cart 1 and the graph we have given to us. So we have to find based on the slope of the line of best fit that determine the combined mass of the two masses. So to find the combined mass. So here they mention they deformed and holds the cars together. So the both cars now stick together. This means that this is the hit and stick rebound. So if this is a hit and stick, so here's the thing we know from here. We have to find the slope first. So if we need a slope, so we have to figure out that what is going on in this. So there's a hit and stick. So we know that P1 plus P2 is equal to P1 to final. So this means that M1 V1 plus initially m2 v2 initially is equal to mass of both and the final form. So that's we all know. But in that case, our car2, it starts from initially at rest. So it's initially at rest so that this one goes out. So if this one goes out, we left it only m1 v1 is equal to m1 plus m2 and v1 to f. So when we want this one because we want a combined mass of cars, so that goes over there and we get this. From here, as we all say that this is the speed of kart 1 before the collision. So if it is before the collision, it means this is a v1 and this is speed of the cars 1 and 2 after the collision. It means this is the combined final velocity. So that's why we move this v1 to final over there to make this stuff in the y-axis. And if we manipulate this again, that m1 upon m1 plus m2 goes over there and this divides with this. So when it divides with this, so this is our x component and this is our y component. So this is y, this is f, so this is our slope. So we get slope of m1 upon m1 plus m2. And we want that combined mass of both. So where we want that m1 plus m2. And we have m1 of 1.54 kg given to us. So once we get the slope, so we can calculate this thing. Know that what is the slope? So slope is y2 minus y1 and s2 minus s1. So I have to take the 2 points from the graph to put over there and get the slope. So best fitted points in this graph, one side at this one, this is the best fitted point, and this is the point is 1.4 comma 0.4. So it's in centimeter per second and this is also centimeter per second. So which it doesn't matter, we take exactly those units we have. And one point over there we have, this is a z point, so we take it as 6.0 comma 2.6. So but it's approximately, so there are different answers and if there's a slight variations in the answers, so it's also marked as correct. So we get 2 points. So this one is x1 y1 and this is x2 y2. So we get 2.6 minus 0.4 upon 6.0 minus 1.4. And we get slope of about, when we calculate this, 0.47826. So there's no units because both have centimeter per second and they cuts out. So that's how you can find. And now you want this, I take m1 plus m2 as big M. It's easy to calculate. So this big M goes over there and m1 upon slope like this. So m1 is 1.54 kgs, slope is 0.47826, and we get about 3.22 kgs. So this is our mass for the combined mass of the two cars. In S1 we have to define that what type of collision of the two cars we have, last year and last and why. So they mention this is the hit and stick collision. So this means if it is a hit and stick, so it's an inelastic. So this is the inelastic collision. And why? Because kinetic energy is not conserved in that case. That's why it is an inelastic collision. So that's all for this. Learning my simple with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. And now we're only left with the one topic of this unit, which is the combining the conversation laws. So see you in the next lesson. Till then, stay connected with EduVibe.